Yes, guys. So today I'm taking questions based on circumcircle, incircle, and excircle. So of a triangle. Okay. So now questions I'm taking. Right. All those formulae which we have discussed in the previous lecture series, they are applicable to solve these questions. All those formulae are just repeat here. After that, I'll take the questions. Okay. All these problems are taken from the students' queries in the class as well as online queries. So please, if you want to ask me any question online, you can just write the feedback, and I'll just take the question. Okay. I try to take almost all the questions I take, but if some questions are left, then I'm sorry for that. But due to the lack of space here, okay, so limited questions I can take, but I'll take the important questions related to the topic, not unrelated topics. Okay. Now let me take these questions. Before that, let me take all those 8 formulae which I discussed in the previous lecture series again and again. Those questions are, those formulae are applicable just to solve these questions. Let me first write what are those formulae related to circumcircle, incircle, and excircle of a triangle. Okay. First, let me take circumcircle. So, formulae to be used. This is questions based on circumcircle, incircle, and excircles of a triangle. Now, formulae based on circumcircle, then incircle, and excircles. And excircles. This is excircles of a triangle. Let me take ABC is the triangle. Any triangle we can take, but I always take ABC so that it is suitable to just describe the topic here. Okay, so let me take all those formulae which are related to these 3 topics. First formula I'll take: if capital R be the radius of the circumcircle of a triangle, take ABC, then the formulae are, first formula is R is equal to, there are 2 formulae of this one, and first is ABC. Take either this first or second one. This is for capital S. Capital S is the area of the triangle. Okay. Second formula for this is A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2 times R, or R is equal to A upon twice sine A, B upon 2 sine B, C upon 2 sine C, 2 take to the denominator of this. So then R will be this, or let me write here, or R is equal to A upon 2 sine A, B upon 2 sine B is equal to C upon 2 sine C. These are the 2 basic formulae for circumcircle of a triangle. Radius of a circumcircle, or circumradius. This one is circumradius. Circumcircle radius. Okay. So these are the 2 formulae. Now let me take incircle. If small r is the radius of an incircle of a triangle, let me take ABC triangle, then there are 3 formulae for this. I'll take all those 3 formulae. These 2 I have taken. Let me take these are 2 formulae 1 and 2. Here I am taking further 3 formulae. Which are those 3 formulae related to R? Okay, so let me take first. R is basic formula capital S upon small s, where capital S is the area of the circle, area of the triangle, and small s is the semi-perimeter of the triangle. This is the first formula. Second, we take R is equal to, right, R equal to S minus A into 10. Let me take the first thing is S minus A into 10A by 2 is equal to S minus B into 10 B by 2, or this is, yeah, small s into, this is only this one, S minus A, right, this is second formula we have taken. S minus A, S minus B 10 B by 2 equal to S minus C 10 C by 2. Okay, this is second formula. Third formula is small r is equal to 4 capital R. That is, capital R is circumcircle, radius of the circumcircle. Small r is the radius of the incircle. Then this is 4 into R into sine A by 2, sine B by 2, sine C by 2. Okay, there are three formulae for incircle of a triangle. Now let us take X circles. If R1, R2 and R3 be the radii of X circles to the triangle or of the triangle, X circles to the triangle, take to the triangle ABC, then one R1 is equal to first formula is capital, let me take capital S upon small s minus A. R2 will be capital S upon small s minus B, and R3 is equal to capital S upon s minus C. This is first and foremost formula. Second formula, R1, this is, let me take first formula. Second formula is R1 equal to small s into 10A by 2. R2 is equal to small s into 10B by 2. Try to understand this. And this is R3, which is s into 10C by 2. This is second type of formula for X radii. Okay, radii, X radii. Okay, I mean X circles radii, R1, R2, R3. Three types of circles can be there, X circles can be there of a triangle, which I have described in the previous lecture series. Please go through the 23rd lecture series, in which I have described this whole, how these formulae were derived, okay, how they can be calculated from the given figures, geometrical figures, and how the X circles are drawn, how incircles are drawn, how circumcircles are drawn. And all these formulae I have proved already. Okay, so please go through my previous lecture series. Then the third type of formula. This is second type of formula. Okay, third type of formula is R1 is equal to 4 capital R. Try to understand. Just like this is small r1, and but here will be, in first it will be sine A by 2, then cos B by 2, cos C by 2. This is the first R1 value, and R2 is equal to 4 into capital R, no problem, into cos A by 2, sine B by 2, cos C by 2. Then R3, third radii of the circle against the vertex C. So there are three types of X circles with the radius R1. It is against the angle A or vertex A, okay, which is touching the opposite side of this BC. Will touch BC and extended sides AB and AC respectively. So the circle is drawn outside the triangle. This is known as X circle, which I have described in the previous lecture. Please just go through the formula here only I am writing. Okay. Then R3 is, okay, this we have taken 4R. R3 will be 4R into cos A by 2 into cos b by 2 into sin c by 2. This I have already described in the previous lecture series, that in these three formulae, this is to be remembered, that in first R1 there will be sin a by 2, others will be cos b by 2, cos c by 2. In R2 it is 4R cos a by 2, sin b by 2. Sin b by 2 will be in R2, and sin c by 2 will be in third one. Sin c by 2 will be in R3. There are 8 formulae which are important, which will be used to resolve these questions. Let me find what is the solution of these questions which I have taken here. Let me take the question now. Okay, so these are the formulae, very important. Please remember them so that we can apply all these formulae to solve the questions. Okay, now let me take all these questions one by one. Very important questions are taken, because from students' queries I have found that most of the questions are university questions. Okay, they have been appeared in some of the university exams. Okay, so please go through these questions which are very important, how they are solved. I'm just going to drive them and solve them, and after that you will find that okay, this is the process. To apply the formula, we have to just solve these questions. Now, question number 1 says, what is question number 1? To prove. What do we have to prove here? To prove here that 1 upon R1 plus 1 upon R2 plus 1 upon R3, okay, is equal to 1 upon R, where this is small r is R1, R is incircle's radius, radius of the incircle. R3, radius of the X circle against vertex C, okay, opposite to vertex B. This is R2, radius of the X circle. R1 is the radius of the X circle opposite to vertex A. Okay, so R1, R2, R3 is the formula. Now let me take the left hand side and solve the reach up to the right hand side. This is we have to prove where R1, R2, R3 have their usual meanings. Usual means the same meanings, means R1 is for X circle against the point A, R2 is the X circle's radius, radius of the X circle, okay, opposite to vertex B, and R3 is the radius of the X circle opposite vertex C. So those three types of circles, X circles, are described in previous lecture series. Please go through that, and you will get first-hand information. And let me take this question. Solution here. In the solution, let me take left hand side. Both sides we have to prove here. Left hand side is 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now we have to put the value of this and reach up to the right hand side. Now let me take S upon, okay, S minus C, S upon S minus B, S upon S minus C, this kind of formula here. Okay, so this 1 upon R1 is capital S upon S minus A plus 1 upon capital S upon S minus B plus 1 upon capital S upon S minus C. Since the first formula which I described in the previous, of X circles formula, since R1 is equal to capital S upon S minus A, R2 equal to capital S upon S minus A, and R3 equal to capital S upon S minus A. So these formulas we are taking, and this, okay, and this. These three formulas were applied here, but this is 1 upon this upon this. This S minus A will come in the numerator. So this is small s minus A upon capital S, small s minus B upon capital S, small s minus C upon capital S. What is the capital S? Is area of the circle. Capital S denotes area of the triangle, circle. Area of the triangle here, ABC triangle we have taken, and S minus A, small s is the semi-perimeter of the circle. Okay, so that, of the triangle. This is the triangle that we take. This is A, B, C if I take, and then X circle is drawn, R1, R2, R3, as I tell you. The circle here, we take bisectors of these two angles B and angle C, exterior angle of B and exterior angle of C. And this suppose this I point from this I we draw perpendicular to these sides. This is perpendicular here and this is perpendicular here. If I join this point here, then the circle drawn, this is G point, this is E point B2, this is F point B2. Okay, the circle which is drawn touching the exterior side or side from external, I mean from outside, is the circle here. This is X circle with radius is R1. This is R1 here. This is R1 here. The perpendicular drawn from I. Let me take this is I1. This is X circle R1 with radius R1. If I take this B and this is A, B, C, so AC, okay, then again we will draw the perpendiculars. We will take angle bisectors which will meet at I2. Okay, then this radius will be R2, this R2, R2. And then X circle is drawn. That circle is X circle with radius R2. Similarly, if it is C point, C, this is A, B, C. Okay, C point. So against C point, if we draw circle, X circle like this. Okay, then R3 will be the radius. So this is these X circles which are described in. These are values of X circles. I mean, radii of the X circles. R1 this, R2 this. All these values we have substituted here. Now here we see capital S, which is area of the triangle. Here capital S is under root S into S, since capital S is this area. S minus A, S minus B into S minus C. This is area of the triangle. Capital S denotes area. S we have taken LCM. Will be S minus A plus S minus B plus S minus C. What is this? Is 3S S plus S minus, and this is negative A plus B plus C. We have taken minus sign common from minus A minus B minus C divided by capital S. Okay, this is capital S. This is 3S. Now this A plus B plus C is twice S. This is minus twice S divided by capital S. This is capital S here. So what do we get? This is small s upon capital S. This is, let me take first equation. So the value of the left hand side is small s upon capital S. If we obtain that right hand side is also of the same type, okay, or we can just say this is can be written as 1 upon capital S upon small s. Okay, so let me take now right hand side. And right hand side RHS is equal to 1 upon small r. Now since small r is equal to capital S upon small s, this is the value of small r. I have written down the formula in the beginning, so please just see there. Let me substitute this 1 upon capital S upon small s. It will be small s upon capital S. This is the same value which we obtained here. This is second equation. From first and second, what we see? From first and second, we get left hand side equal to right hand side. Hence proved. It has been proved here. We can say same result has been obtained in left hand side, right hand side. They are equal. It means this is the process of solving these questions. Okay. Let me take now second question. Question number 2 now. Question number 2 or second question. Now question number 2. What does it say? Question number 2 here. Now it says prove that. Okay, let me take. Prove that what do we have to prove here? That A into B, AB minus R1 into R2 divided by R3, okay, is equal to BC minus R3, I'm sorry, is R2 into R3. This is R2 into R3. All Alright, this is R2 into R3 divided by R1, okay, divided by R1 is equal to CA minus R3 into R1 divided by R2. Okay, these are the values we have to prove that this whole is equal to R, small r. Okay, let us take this. So all these values are equal. Let me take one and second and third, and let me prove that all these are equal to small r, value of in-circles radius. Okay, so let me take solution. What do we have the solution? Solution here we have a into b minus r1 into r2 divided by r3. Let me take this here, r1 r2. If I substitute, then ab minus, this will be r1 is capital S upon S minus a, into this is capital S upon r2 is S minus b, within bracket, whole divided by r3. Let me take r3 as it is. Finally, I'll substitute the value of r3. Let me take r3, 1 upon r3 common. If I take ab common here, okay, so it will be, okay, let me take, this is, if I take ab common from this bracket, it will be 1 minus s square, this is s square here, or let me take s upon, okay, let me take s upon S minus a into S minus b upon AB. This AB is also there. AB is also there. Okay. Into S, this is S square here. 1 upon R3 I have taken before. So what is this? Let me take. If I write it as okay, this is S minus A, S minus B, and if I substitute the value of, okay, small s here with the value of small s, now cos c by 2 we have obtained, or if I multiply this by S minus A, this is S into S minus A, okay, R2, this is R1 and R2, R1 was S upon S minus A, and R2 was S upon S minus B. Okay, this is S square upon this AB I have taken common, so this is 1 minus this AB here. Alright, but let us say, okay, so this can be written as under root of this and S upon this whole square, we can write. So that will be, this is 1 upon R3 into AB, within bracket it will be 1 minus, if I write it as S upon, but value of S is under root. If I write under root, S is under root, but S is without under root. Let me write here, without under root here. So this is S square. S means S into S minus A into S minus B into S minus C. Area of the circle, sorry, area of the triangle. S into S minus S upon S minus A into S minus B into AB given to us. I've substituted the value of area of the triangle S, capital S. But S is under root, S square is square root cancelled out. The value is S minus A cancelled out, S minus B cancelled out. Okay, so this can be further put down. 1 upon R3, this is out. 1 minus, this is nothing but S into S minus C upon AB. Try to understand. Now we can write it as under root of this and whole square of this. Let me write it above. Let me write it here. Okay, so we have now obtained this value 1 upon R3 into ABB2 comma. This is 1 minus S into S minus C. I can write it as S into S minus C upon AB, the square root of this, whole square of this. No change. No change. Why? Because this is square and square root cancel out. Same value S into S minus C upon AB will remain. What is this value? Now under root S into S minus C upon AB is sin C by 2. Sorry, cos C by 2. This is cos C by 2 value. What is cos square C by 2? See, nothing but this value is 1 upon R3 into AB, which we took common. This is 1 minus cos square, this is cos C by 2 whole square. Cos C by 2 whole square. Why? Because cos C by 2, since cos C by 2 is equal to under root S into S minus C upon AB. This value we know what? Cos C by 2 from solution of triangles. From solution of triangles, this value of cos C by 2, this is under root cos this S into S minus C upon AB is cos C by 2, cos C by 2 whole square. That means cos square C by 2. It is nothing but 1 minus R3 into AB into 1 minus, this is cos square C by 2. What was this? This is 1 upon R3 into AB. 1 minus cos square theta is sin square theta. It will be sin square C by 2. Sin square C by 2. What is the value of sin square of sin C by 2? Let me write. So finally, we obtain here value of sin C by 2. Let me write. This is AB upon R3. Now R3 is S upon S minus C. Capital S upon small S minus C. R3. I have substituted the value. And sin square C by 2 will be nothing but S minus B into S minus C upon BC. This is for C by 2, I'm sorry. This will be A, B. S minus A, S minus B and divided by AB. Because this is whole square. But sin C by 2 is under root S minus B, S minus C. So this C by 2 is there. It will be under root S minus A, S minus B upon AB. S minus A, S minus B upon AB under root. But this is whole square and square root cancel out. This is only this value. Now here we see AB and AB cancel out. S minus C will come here in numerator. It will be S minus C into S minus A into S minus B divided by capital S. Divided by capital S. Okay. Now if I substitute this value, if I multiply this by S, okay, or S square, let me multiply by S, capital S by capital S. What is this value? In the denominator we have S square. Numerator we have S into S minus C into S minus A into S minus B whole divided by S square. Try to understand. Now S again A is what is the area of a triangle by S denote S into S minus A, S minus B, S minus C. This is a whole square. So square root and whole that cancel out. This is capital S into S minus A, S minus B into S minus C. S square means S into S minus A into S minus B into S minus C square is cancelled out. Why? Because since capital S is under root S into S minus A into S minus B into S minus C. This is the value of S. But this is S square. So this is square root, cancel out. From here we see S minus A cancel out, S minus B, S minus B, S minus C, S minus C cancel out. Only capital S upon small s is the remaining value. Now what is this? Small r value. This we know that this is small r, because small r, which is radius of the inner circle, is capital S upon small s. This we know about. Okay, from formula. This is small r. We see here left hand side, one part is equal to small r. Similarly, we can prove other two parts. If we take one more, so that it can be further solved. Okay, so this first part has been driven to the value this. Now we have BC into this. BC minus R2 into R3 divided by R1. Okay, now we have this. Now we have second part. Similarly, we could say similarly this equal to R, this equal to R. Where we take this second part. Again BC, if I take common, this is BC upon R1. I've taken 1 minus R2. Value of R2 is S upon S minus B into capital S upon S minus C upon BC into BC. This is into BC. BC also we have taken here, so this is equal to BC upon R1, because BC we have taken common. This is 1 minus S square is in the numerator. Again put S square value, that is S into S minus A into S minus B into S minus C. Value of S square divided by S minus C and S minus B cancelled out. S minus B and S minus C into BC is S minus B, S minus B, S minus C, S minus C cancelled out. We obtain BC upon R1. In bracket it is 1 minus S into S minus A upon BC. What is this value? This is value of cos A by 2, because S into S minus A in the numerator upon BC. This is value of cos A by 2. This is cos square A by 2. Right? So this is the value of cos square A by 2. So this is whole equal to BC upon R1. The second part we are taking this. In the first part we have taken this third part. Is whole equal to R. That we are proving. This is 1 minus, because this is value of